Hi everyone and welcome to my channel. My name is Mohammad Ismail. I am a first year student in the Bachelor's of Engineering in Computer Science and Engineering with the specialization of Data Science in Sri Venkateswara College of Engineering, Bangalore. My USN number is 1VE23CD030 and today's subject is Mathematics 2. Subject code is BMATS202 and today's topic is Integral Calculus. Calculus is a powerful branch of mathematics with two main parts, differential calculus and integral calculus. Differential calculus is like taking things apart, focusing on rate of changes and slopes. Integral calculus on the other hand side, it is about putting things back together, dealing with the accumulation areas. Today we will dive into the world of integrals calculus where we will learn to find the whole from its infinitely small pieces. Next we will say what is integral calculus. Integral calculus is the study of integration, the inverse of differentiation. It allows us to find the area under a curve, the volume of solid and many other applications. The symbol for integration is the elongated. Means imagine you have a bunch of broken piece of puzzles. Differential calculus help you to analyze the individual shapes and edges of those pieces. Integral calculus, however, is the magic that lets you reassemble those pieces to form the complete picture. It's about finding the whole from its infinitely small parts. The integral sign becomes our tool for the reunification process. Next we will move on antiderivatives and indefinite integrals. An antiderivative of a function f of x is the function capital F of x whose derivative is f of x. In other words, f dash of x is equal to f of x. And the process of finding the antiderivative is called indefinite integrals. The indefinite integrals of f of x is denoted by integration of f of x dx, which reads the integral of f of x with respect to x. Let me take one example. Think of antiderivatives as the undo button for differentiation. If differentiation breaks down the functions into its rate of change, the antiderivative puts those pieces back together to form the original function. The indefinite integrals are denoted by integration of f of x dx represent all possible antiderivative of f of x, because adding a constant c to any antiderivatives will also result in the function whose derivative is f of x. This constant c accounts for the different possible starting point for the reassembled function. Next we will move on to the fundamental theorem of calculus. The fundamental theorem of calculus bridges the gap between differentiation and integration. Means the fundamental theorem of calculus is a cornerstone of integral calculus. It establishes a beautiful connection between the two main operations. Next part 1. If f is antiderivative of small f, f dash of x is equal to f of x. Then integration of f of x dx is equal to f of x plus c. Means part 1 tells us that the integral of the function is essential. Its antiderivatives plus an arbitrary constant. Next part 2. If f is continuous on the interval a b, then integration of a to b f of x dx is equal to f of b minus f of a. Part 2 shows us how to calculate the definite integral of a function over a specific interval. These definite integrals represent the net change or total accomplish of the function's value with that intervals. Next we will move on definite integrals and applications. A definite integrals integration from a to b f of x dx calculates the area under the curve of f of x between x is equal to a and x is equal to b. Next, we can subdivide the area into thin rectangle. Some the areas and take the limits as the number of rectangle tends to infinity. Next, definite integrals have numerous applications in physics, engineering, economics, and many other fields. They can be used to find distance traveled when velocity is given, work done when force is given, by slicing volume of solid. Many other quantities involves accumulation or change. Next, we will move on to techniques of integration. There are several techniques to solve indefinite integrals. Means just like having the right tool for the job makes things easier. Integral calculus has a toolbox of techniques integrals. Some common techniques include U substitution. U substitution allows us to substitute a new variable to simplify the integration process. Next, integration by parts. Integration by parts is a powerful technique for integrating the product of two functions. Next, trigonometric identities. Trigonometric identities comes in handy when integration functions involves trigonometric terms. Finally, partial fraction. Partial fractions help us to break down the rational function into simpler functions that are easier to integrate. Next, we will discuss one by one. U substitution, change of variable. U substitutions allows us to change the variable in an integral to make it easier to solve. We define a new variable u is equal to u of x and substitute it into the function and its derivative du is equal to u dash of x dx. The integral transforms from integration of f of x dx to integration of f of u of x modulus of u of x dx. Means imagine you are trying to integrate a complex function. U substitutions comes to the rescue by letting you choose a new variable u that transforms the integral into a more recognizable form. You substitute the function and its derivative in terms of u and adjust from the change in variable using the absolute value of u dash of u dash of x. These techniques allows you to leverage your knowledge of basic integrations rule to solve the transformed integrals and then substitute back to find the solution in terms of original variable. Next is integration by parts. Integration by parts is a technique for integrating the product of two functions. It utilizes the following formula. Integration of u of x v dash of x dx is equal to u of x v of x minus integration of u dash of x v dash of x dx. Next, we strategically choose functions u and v such that one integrate easily and the other differentiate easily. Means integration by parts tackles the challenge of integrating the product of two functions. It's like a seesaw. On one side we aim for a function that integrates easily u and on the other side we want to function whose derivative integrate easily v dash. The formula provides a clever way to transform the integrals into a difference of two integrals where one is often easier to solve. By strategically choosing u and v, we can break down the problems and find the solution. Next, we will move on. Applications of definite integrals. Definite integrals have a numerous real-world applications. Some example includes finding the area enclosed by a curve, shaded regions under a graph, calculating the distance traveled, definite integral of velocity function, determining the work done, definite integral of force function, computing the value of a solid by slicing. Next, we will move on to conclusion. Integral calculus serves as a powerful tool in understanding and solving a wide array of problems across various fields. From physics and engineering to economics and biology, By providing a method to calculate area, volumes, and accumulated quantities, integral calculus enable us to model real-world phenomena with precision and make informed decisions. As we conclude our journey through integral calculus, let us appreciate its significance in advancing our understanding of the world around us and its indispensable role in shaping the modern scientific and technological landscape. Thank you for watching. If you have any doubt, please comment it. Please like, share and subscribe my video. Thank you.